This is the Unit 4 test review. Number 1. There are 25 boys and 30 girls going on the 6th grade field trip. What is the ratio of girls to boys written as a fraction in simplest form? All right, so I want to make sure I write my ratio the way they've asked for it. So I need to do girls to boys, so girls over boys. And then I can see that there are 30 girls to 25 boys. All right, so that's a fraction, but it's not in simplest form, so I need to go ahead and simplify it. These are both divisible by 5. That would be 6 over 5. And that is simplified, so my ratio simplified is 6 over 5. Number 2. The table shows the number of vegetable plants planted in Sophia's garden. Express the ratio comparing the number of tomato plants to the total number of plants as a fraction in simplest form and as a decimal. All right, so they're asking for the number of tomato plants to the total. So tomato over total. And so tomato, there are 10 tomatoes, and then the total, I need to add these up to find. 5 plus 5 is 10, 1 plus 2 is 3, plus 1 is 4, plus 1 is 5. So over 50. And this is 10 over 50. And then to simplify that, I need to divide it by 10. That gives me 1/5 as a fraction. And I also need to change it to a decimal. So I'm going to do top in, bottom out, divide that. 5 won't go into 1, so I add my decimal and a 0. 5 will go into 10 2 times. So as a decimal, this is 0.2. Okay. Number 3, it says Miss Kavanaugh's chocolate chip peanut butter cookie recipe calls for 2 cups of peanut butter for every ½ cup of chocolate chips. Mrs. Fox's recipe calls for 1½ cups of peanut butter for every ½ cup of chocolate chips. Which statement is true about Miss Kavanaugh's and Miss Fox's recipes? So Miss Fox's cookies are more chocolatey than Mrs. Kavanaugh's cookies. Miss Kavanaugh's cookies are more chocolatey than Mrs. Fox's cookies. Okay, so what I want to know is basically the ratio of chocolate to peanut butter. All right, so if they're more chocolatey, then the chocolate's going to be more than the peanut butter they should have. It should have if I'm comparing chocolate to peanut butter, then I should get a number. So whoever has the biggest ratio basically will have more chocolate. So I want to go ahead and find that for both of these. Kavanaugh's chocolate chip, so 2 peanut butter for ½ cup of chocolate chips. So that would be 0.5 chocolate and 2 cups of peanut butter for Miss Kavanaugh. And then for Miss Fox, that would be, let's see, 0.5 chocolate to 1.5 peanut butter. Okay, so if you're not sure, okay, then you can go ahead and divide these. So 0.5 divided by 2. Okay, you can divide 5 into 2, or yeah, 5 and 2 into 5 2 times would be 4. When I subtract, I get a 1, bring down a 0, so that's 0.25. So as a chocolate ratio to peanut butter, this would be 0.25. And then if I do the same thing for Mrs. Fox, this is Kavanaugh, this is Fox, then I'm going to divide 0.5 by 1.5. So I'm going to move my decimal. So I'm actually dividing 15 into 5 point something. So I'm going to bring up my decimal and add a 0. 15 will go into 50 3 times, so that would be 45. That's going to give me a 5. So this is actually going to repeat, the 3, or 0.33. So this, Miss Kavanaugh has a ratio of chocolate to peanut butter that's 0.25, and Miss Fox has a ratio of peanut butter that's 0.33. So I want to know who has the more chocolatey amount, and that would be Mrs. Fox has a bigger ratio of chocolate. They're definitely not equivalent, and there's definitely enough information to compare them. So I'm going to go with A, because the ratio of chocolate to peanut butter is higher for Mrs. Fox. All right, on number 4, Missy works at Clark Grocery Store. The table below shows the number of hours she worked each week last month and the total amount of her paycheck before deductions. What is Missy's hourly rate? All right, so if I just want an hourly rate, I want the rate for 1 hour. So that's a unit rate, which means I'm just dividing the amount she earned by the hours she worked. And I only really have to do this once because her hourly rate doesn't change. Her hours may change and her amount may change, but the rate at which she is paid doesn't change. So I can just pick the one I think might be the easiest to divide and use that one. So since 12.8 and 119 seem to be a little smaller, I'm going to go with those. So I'm dividing 12.8 into 119.68. I'm going to move my decimal and then actually divide 128 into 1,196.8. All right, so I can divide 128 into 1,196. It'll go, well, I don't know how many times it'll go. So 128, let's try 9. 2, 7, 18, 25, 2, 11. Okay, so that's pretty close. So 9 times was 1,052. I subtract, I get 44. I'm going to bring up my decimal and bring down my 8. 128 into 448. And let's say that'll go 3 times maybe. 128 times 3 would be 24. Carry your 2. 3 times 2 is 6. Plus 2 is 8. And then a 3. Yep. So that would be 3 times. I'm subtracting 384. That gives me 464. And I'm going to bring down a 0. And then 128 times 5 would be 640. Perfect. All right, so 5 times is 640. So that tells me that she is paid $9.35 per hour. Okay, and again, whichever set you use, you should end up with the same answer. So just pick the ones you think are easiest to divide. Number 5, Jeffrey Mutai won the 2013 New York City Marathon with a time of 2 2/15 hours. The yearly event is a 26 1/5 mile run. If Jeffrey runs at a constant rate, how many miles did he run per hour of this marathon? Okay. So per hour means for 1 hour. So it's the miles per hour. So that means it's the number of miles over the number of hours, 2 and 2/15. So miles over hours. So again, I'm finding a unit rate. I'm using division. So I'm going to divide 26 1/5 by 2 and 2/15. I can do that probably just with fractions. So if I go ahead and can make these improper, 5 times 26, I would need to know that. Is 30 is 130 plus the 1 gives me 131 over 5. And I want to divide that by the bottom. This is called a complex fraction, by the way, because you have fractions inside the fraction. But they work the same way as division, so just do what you would normally do to divide fractions. 15 times 2 is 30, plus the 2 is 32 over 15. And I know if I'm dividing fractions, I'm going to use keep, change, flip. So I'm keeping that, changing to multiply, flipping this to the reciprocal of 15 over 32. All right, and then I'm going to cross simplify. So I know that this doesn't simplify and this doesn't simplify, but 5 and 15 both divisible by 5. So 5 divided by 5 is 1, 15 divided by 5 is 3. So now I only have to multiply 131 times 3. So if I do that, 131 times 3, I get 393 over 32. All right, and so then I just want to convert this back into a mixed number. So if I divide 32 into 393, I'll go 1 time with a remainder of 7. Bring down your 3. 32 will go into 73. Let's say 3 times is too much. So 2 times 32 is 64. So that would be a remainder of 9, and I'm going to keep it as a fraction. So this is going to be my whole number, 12. My remainder is my numerator, and my denominator is still 32. Okay, and 9/32 is simplified, so I am done. Is that right? Let's see. Yes, I think that's correct. Okay, moving on. Number 6. General Electric Company makes 4 light bulbs using different amounts of electricity, as shown in the table. What is the average number of watts used per hour? So again, this phraseology per hour is really just asking you for a unit rate. Remember, we're dividing unit rate, UNO rate, and you're dividing to find the rate for 1 hour. Let's see, so what is the average number? So since I'm finding the average number of rate per hour, what I'm gonna need to do is add up all the watts and add up all the hours and then divide to find the unit rate. So that would be my first step, is to add all this up. So 400 plus 200 plus 180 plus 140. That's 0, 12, let's see, 1 plus 4 is 5, 6, 7, 8, 9. And then if I add up all the hours, 10, 8, 3, and 4. So 8 plus 3 is 11, plus 4 is 15, be 25. Right, and then now I can set up my unit rate. So I'm trying to find the watts per hour. So 920 divided by 25. And when I go ahead and typo that, 25 will go into 92, say 3 times is 75. When you subtract, you're gonna get 17, bring down your 0. 25 will go into 170. 6 times would be 150. You get 20. If I add a decimal, bring down the 0. 25 will go into 208 times, and then I can stop. All right, so if I interpret that, what I'm saying is that the average amount of watt used per hour, so 36.8 watts for every hour, well, the average is 36.8 watts per hour, right? So this is a little different than finding the hourly rate, because the hourly rate is always the same, whereas when you're finding an average number, that's telling you that the rate is changing, and so that's why we had to do it a little differently, where we were finding the total of these separately and then finding the average. Okay, by dividing. Number 7, store A sells a 100-ounce bottle of cleaner for $12.99. Store B sells the same cleaner for $9.49 for a 70-ounce bottle. Store C sells a 90-ounce bottle of the same cleaner for $10.98. Which store has the best buy for the cleaner? All right, so when you're comparing for the best buy, you need to know the unit price, all right? And unit price is always the price on top, so that's going to be divided by the quantity, all right? So in this first one, it's $12.99 divided by 100, so that's $12.99 over 100. So when you divide that, $12.99 goes inside and the 100 goes outside. All right, so 100 will go into, won't go into 12, it'll go into 129 one time. When you subtract, you get 29, bring down your 9. 100 will go into 299 2 times. And then when you subtract 200, you get 99. If I add a 0 and keep going, 100 will go into 999 times. And then I could go ahead and finish this, but really, because I'm talking about money, I didn't have to go this far. So this is 12. I want this to be in cents, so that means I'm rounding to the nearest hundredth. So I'm looking at 9 in the thousands place. It's greater than 5. So this is going to be about 13 cents for each ounce. All right. And the next one I'm starting, store B is $9.49 per 70-ounce bottle. So that's going to go, the $9.49 goes inside, 70 is going outside. 70 won't go into 9, so I'll bring up my decimal. 70 will go into 94 one time. I'm going to subtract and get 24 and bring down my 9. 70 will go into 249 3 times. 3 times 70 is 210. When I subtract, I get 39. I'm going to go one more time so that I can compare these. 70 will go into 395 times. 5 times 70 is 350. And this is going to keep on going. This is enough to round to the nearest cent. So this time, 5 is in the thousands place, so that is 5 or greater. So I'm going to round the 3 up into a 4. So this is about 14 cents per ounce in store B. All right, and then the last store C, I have $10.98 for a 90-cent bottle, or 90-ounce bottle, sorry. So the 90 is on the outside, $10.98 on the inside. So 90 won't go into 10, it will go into 109 one time. When I subtract, I get 19, bring down the 8, 90 will go into 198 twice, which is 180 when I subtract. And keep going one more time. 90 will go into 180 two times. And that one stops. So when I round this to the nearest cent, 2 is not greater than 5, so that's not going to change the first 2. So this is about 12 cents. So the Best Buy, when you're shopping, is the cheapest one. So since 12 is the cheapest, 12 cents per ounce, then that would be the store C. Okay, so just remember with unit price, the price is always on top. Number 8, Mrs. Carson makes cookies for a Halloween party. The recipe calls for 7 1/5 cups of flour to make 4 dozen cookies. Expressed as a decimal, how much flour in cups does this recipe use per cookie? Record your answer and fill in the bubbles on the grid below. Be sure to use the correct place value. So again, I'm doing per cookie. This tells me I'm finding a unit rate, so I want to do the number of cups of flour per cookie. That's how I want to set this up. The rate they give me is 7 1/5 cups for 4 dozen cookies, so make sure you change that into a number of cookies. So dozen is 12, 4 times 12 is 48, so for 48 cookies. I need to divide 48 into 7 1/5. I can do that as a fraction if I want, or I can go ahead and change this to a decimal since I need to find a decimal anyway. So if I want to change 1/5 into a decimal, it's going to be a 0.2. This is 7.2 divided by 48. If you want to work with the fraction first and change it to a decimal at the end, you can do that too. You should get the same answer. So I'm dividing 48 into 7.2. Won't go into 7, so I'll bring up my decimal. So 48 will go into 72, not twice. So when I subtract, it's going to give me 4, and 6 minus 4 is 24. I'm going to bring down a 0. So 48 will go into 245 times, I believe. Let me check that. Yep. All right, so 240. So that tells me that my rate is going to be 0.15 cups of flour per cookie. And then since I'm putting it in this griddable over here, since the decimal is in front of the 1, and the 1 and 5 are going to come at the end here. So 1 and 5. Just make sure you bubble those in completely. That's just kind of preparing you for tests that use a Scantron. All right, number 9, during a field trip to a local soda manufacturing plant, students watched as 12 sodas were dispensed in 1.5 minutes. At this rate, how many sodas does the factory dispense per hour? So again, that terminology is looking for a unit rate. I'm doing the sodas compared to the hours, so that tells me sodas is going on top. So it's 12 sodas in 1.5 minutes. Okay, hang on. 1.5 minutes. And so I really want to know what that means in an hour. So in an hour, okay, so really this is, if I change this to minute, because this was 1.5 minutes, an hour would be how many minutes? 60 minutes. So actually I can solve this one with a proportion because per hour is using a different measurement. All right, so if I go ahead and use a proportion for this, then I'm going to multiply across diagonally first. So 60 times 12 gives me 0, 12. Start with a 0. 0, 6 is 720, and then I still need to divide by 1.5. So I'm going to add a decimal so I can move this over and divide 15 into 7,200 now. So 15 will go into 72. Let's say, yeah, 4 times would be 60. When I subtract, I get 12. Bring down the 0. 15, I'll go into 120. Well, if I double that, that's 8. 40, yeah, 120. And then I'm going to bring down my last 0. 15 will go into 0, 0 times. All right. So how many sodas can the factory dispense per hour? So that's 60 minutes. And we said that would be, this would be 480 sodas. Okay, I'm going to do one more and then I'm going to stop this video and we'll pick up the rest of the review in part 2. All right, so Molly reads 12 pages from her book in 18 minutes. If she continues reading at the same rate and the amount of time changes by a factor of 7/6, how many pages will Molly read? Okay, so I'm doing pages compared to minutes. And the first set of numbers they give me is 12 pages in 18 minutes. And then we want to do this again. I'm looking for the number of pages, but the time they don't really tell me. They just tell me that the original time, 18 minutes, has changed by a factor of 7/6. So I have to figure out that time before I can substitute it in here. So factor means a multiple of 7/6. So I'm going to take 18 minutes. I'm going to multiply it by 7/6. So I'm going to make that 18 over 1. I'm going to cross simplify because that's faster. So these are both divisible by 6. 6 divided by 6 is 1. 18 divided by 6 is 3. And then I just have to multiply. 3 times 7 is 21 over 1, which is just 21. Okay, if you want to work it out, you can. It's just going to take you a little longer. So that was the time that changed. So that's going to make it 21 minutes down here. And then I'm just going to solve like a regular proportion and multiply my diagonal numbers first. 12 times 21. 1 times 2 and 1 times 1. Start with a 0. 2 times 2 is 4. 2 times 1 is 2. And then add these up. 252. And then I still need to divide by 18. So where am I going to do that? 18 into 252. 18 will go into 25 once. I subtract, I get 7. Bring down the 2. 18 will go into 72 4 times. Yes, 4 times. Okay. So 14, that tells me she can read 14 pages in 21 minutes. All right, we'll continue this in part 2.